In the previous video, we saw how to write these integrals in right Riemann summation. The video was too long, so now the left Riemann summation will be in a separate video in this video. So again, we have a function. This function, we are finding the area from A to B. This area, this is the integral from A to B of f of x dx, because the height of each rectangle is f of x, the width is delta x, and the width is the same for each rectangle, so we will sum each one of the areas. So the delta x is in common and f of x is in common, but the x is changing from A to B. So this will be the same as we already expressed this in a left Riemann summation in notation in previous videos. So this is the limit as n approaches infinity of summation from traditional way from left Riemann sum is I equals 0 to n of f of x sub I times delta x. F of x sub I is the height. Now this we can put it as the limit as n approaches infinity of summation from I equals 0 to n of f of what's x sub I, we saw is a plus delta x times I. This is x sub I. So f of a plus delta x sub I times delta x. Or the non-traditional way, that is the limit as n approaches infinity of summation from I equals 1 to, sorry, here was always n minus 1, of n of f of x sub I minus 1, because we're upping here, so we need to go down here. And this is the same as the limit as n approaches infinity of n of the sum from I equals 1 to n of f of a plus delta x, instead of multiplying times I, is times I minus 1, and everything times delta x. So the first one, this will be, remember the steps. We first need to find delta x, next x sub I, and next f of x sub I, and at the end we put the summation. So delta x is the width of each rectangle, that is b minus a divided by n. So here the n is the number of intervals, but we are trying to approximate the area as much as we can, and this is when we have infinity many rectangles. So here the delta x is pi minus 0 over n. This is pi over n. Our x sub I will be, what's a? We are beginning from 0, so our x sub a is just pi over n times I. And our f of x sub I will be, you are doing in the traditional way, so our f of x sub I will be cosine of pi over n over n I. Now here the summation, this will be the limit as n approaches infinity of this sum from I equals 0 to n minus 1 of cosine pi over n I times delta x. Delta x is pi over n. If you see in the previous video, we have the same thing for the right Riemann sum, but remember that instead of going from I equals 0 to n minus 1, it's from I equals 1 to n. Or you can put it as limit as n approaches infinity of summation from I equals 1 to n of cosine of pi n times I minus 1, and everything times pi over n. The second one, delta x is 5 over n. X sub I will be 2 plus 5 over n I. we are doing in the traditional way. Or if you want in the non-traditional way, it would be 2 plus 5 over n I minus 1. And our f of x would be just plotting that here. So the second one is the limit as n approaches infinity of summation from I equals 0 to n minus 1. Let's do the traditional way first. Of natural logarithm of 2 plus 5 over n I times 5 over n, or the limit as n approaches infinity of the sum from I equals 1 to n of the natural logarithm of 2 plus 5 over n times I minus 1 times 5 over n. Here delta x is 3 over n, x sub I will be 3 over n I, or the non-traditional way would be 3 over n times I minus 1. So the limit as n approaches infinity of the sum from I equals 0 to n minus 1 of e to the 3 over n I times 3 over n, or the limit as n approaches infinity of the sum from I equals 1 to n of e to the 3 over n times I minus 1 times 3 over n. This one, delta x is 5 over n, a is equal to 0, x sub I is 5 over n I. This is the traditional way, and f of x sub I will be 5 over n I plus 1. So is the limit as n approaches infinity of the summation from I equals 0 to n minus 1 of f of x will be 5 over n I plus 1, and everything times delta x. Delta x is 5 over n. This is the same as the limit as n approaches infinity of the sum from I equals 1 to n of 5 over n times I minus 1, everything plus 1, everything times 5 over n. And lastly, this that doesn't depend on I or n, so it's just our delta x is 5 over n. X to y will be 5 over n times I, but there is no need to put it because this doesn't depend on I, so this is just the limit as n approaches infinity of the sum from I equals 0 to n minus 1 of 4, this is f of x, 4, it doesn't depend on I or n anything, times delta x, that is 5 over n, so times 5 over n. And in the previous video we saw that this is equal to 20 if we evaluate this sum. So now you can compare the left Riemann sum with the right Riemann sum, how we pass from integral to that. In the next video we're going to do the reverse order, how we begin with these Riemann summations and we put it in integral way. In the comparison from this and the previous video, you will notice that everything we have right in the traditional way from the left Riemann sum is the same as in the right Riemann sum, but instead of beginning from I equals 0 to n minus 1 is from I equals 1 to n. And here is the non-traditional way in which we just subtract 1, and we put I equals 1 to n, and in the other we add 1 and we put it from I equals 0 to n to n minus 1. Now remember that if you have a Riemann summation, could be right, left, midpoint, traditional, non-traditional, you can derive every other.